Welcome to Creative World. In this video, we will solve Learning Assessment E2.2. While solving this problem, we will be using Ohm's law, that is V equal to I multiply by R, and electrical power, that is the product of voltage and current. Two additional power formulas will be used in this scenario. One is P equal to I square multiply by R, and other one is P equal to V square divided by R. We also will be using passive sign convention theory. According to this theory, elements with negative power will be considered as power suppliers and elements with positive power will be considered as power absorber. Read the scenario. Learning Assessment E2.2 Part A. Calculate R and Vs in given below figure. This is the figure and we have to calculate Vs in this figure and the value of R. Data is given power absorbed by this resistance, that is 1.6 milliwatt, and current of constant current source, that is 0.4 milliampere. Because of series connection, this current will also flowing through this resistance. First we will calculate the value of R. Before that, we have to add symbols of plus and minus notations across this resistance. Current is entering from this terminal, so this terminal of resistance will be taken with positive sign and this terminal will be taken with negative sign. First we will calculate the value of R. Later on we will calculate voltage Vs, that will be equal to the voltage across this resistance. And voltage drop of this resistance will be calculated, current I through it and resistance of itself. Their product will be voltage across this resistance. So for the calculation of R, we have power of this resistance and current through this resistance. So we will use power formula, that is I square multiply by R. In this equation, power is given, I is also given. We can calculate the value of R. Value of R can be calculated using this formula, R equal to P divided by I square. These two quantities are given, we can calculate the value of R. Enter the value of these two quantities. Power is 1.6 milliwatt and current is 0.4 milliampere. Solve this equation to find the value of R, that is 10 kilo ohm. Now we have the value of R and current through this resistance is also known. We can calculate the voltage across this resistance using Ohm's law. V equal to I multiply by R. V equal to I, that is 0.4 milliampere multiply by resistance, that is 10 kilo ohm. So the voltage value will be 4 volt. This 4 volt drop is across this resistance and because of parallel connection, same voltage will be appearing across this constant current source. So the value of Vs will be 4 volt. Now move towards the next part. Part B. Calculate R and I in given below figure. In this figure we have to calculate value of R and current through this resistance I. Voltage across this resistance is given. First we will mark the notations of plus and minus symbol across this resistance. Because current is entering from this terminal, so this terminal will be taken with positive sign and other terminal will be taken with negative sign. Now first we will calculate resistance and then later on current. For the calculation of resistance we have power and voltage. We will use the power formula, that is P equal to V square divided by R. From this formula we can calculate the value of R. Value of R will be V square divided by P. Now we have these two quantities. Enter the value of these two quantities. Voltage is 12, take its square, and power is 0.25 watt. Solve this equation to calculate the value of R, that is 576 ohm. Now at this stage we know the value of resistance and voltage across this resistance. So we can calculate current through this resistance using Ohm's law. V equal to IR, and for the calculation of I, R will be divided on both sides. So the formula of I will be V divided by R. We have value of voltage and resistance. Enter these values into the equation and find the value of I, that will be 20.83 milliampere. So this was learning assessment E2.2. Thank you. See you again in next video.